This is an example of how you would make an equation in order to create a table of values for certain values. In this case, it cost you, if it was $5 to get into the Ponoka Stampede, and we can put any value that it is, this is just an easy number to work with, and it was $4 a ride if they started charging us to get in there to get to the rides. You'll notice that the $5 entry fee, we pay that no matter how many rides we go on. So it doesn't matter if we go on 100 rides or 1,000 rides or 0 rides or 1 ride. In this case, we would pay $5 just to get in, no matter what. This is called the constant because it doesn't change. It doesn't matter how many rides we go on, that $5 is what we paid to get in. This $4 per ride, that means per. Usually when something says per, that's a giveaway that it is the numerical coefficient. So this becomes this $4, the numerical coefficient. And that is almost always, especially with grade 8 material, tied to your variable, okay? And you can see where it was tied to the variable right here. So it's the numerical coefficient, it gets tied to the variable, and the plus 5 becomes the constant that is attached to it. So it becomes easier to make an equation when you understand what is constant, what does not change, and what is the numerical coefficient. What does change according to how many rides you go on, okay? Again, if this is our output, this t, we would probably want to say that's our end answer, so we'll start with our ends changing. Well, how many rides did you go on? Well, what if I went on 1 ride, 2 rides, 3 rides, 4 rides, 5 rides? Then I can put that into the number here and come up with an output for how much that would cost. 4 times 1, if I'm on my first ride here, 1 ride, 4 times 1 is 4, plus 5 is 9. Go to the 2, 4 times 2 is 8, plus 5 is 13. We'll notice that this is going up by 4s. And you might notice that it's going up by 4s, and that's also the numerical coefficient. That's pretty common when we're doing these kind of equations. What it's going up by in your output, your end result, is usually what your numerical coefficient is. That's really important. Try a 3 now with it. If this becomes a 3, 4 times 3 is 12, plus 5 is 17. And again, we're noticing it's going up by 4. We can now complete the pattern by continuing plus 4 and plus 4 to help us solve an actual question with a real life example.